Okay, so let's talk about the midterm. So this is for everyone who's interested in completing the course, who's shown up this morning, who was in attendance. So what do we got here? We have a midterm that was posted last night to the bhacker.com website. It is underneath, let me go back to September 2013. If you click on Object-Oriented Programming with C++ and you go down to the bottom, underneath all of the recorded lectures, you find the midterm exam take home, and then you see this help file. I'm going to go through both of them actually right now so we can understand what we're doing. You're writing a program, so it's not go to the internet, cut and paste, and turn it in. Instead, you're actually going to write your own program, and you're going to use arrays, because I realized I went through the assignments and I realized that there's nothing in there about arrays. So we're going to use arrays. So how are you going to use arrays? Let's take a look here at the requirements and make this a little bit bigger so we can kind of see it. Here we go. So keep in mind that this is a take-home midterm, and it is due on August 22nd. Even though we come back on the 23rd or 24th, 25th. So you're going to take the final exam after you turn this in, which is, I guess, a good thing. The format for the final exam is multiple choice. It's going to cover the entire course. A midterm is only covering up till the end of this weekend, which is, I figured, one of the topics we probably didn't do very much in terms of the assignments were on arrays. So now you're going to basically practice using arrays. So you're going to write a program that plays a Battleship game. So if you're not familiar with Battleship, it's a, I don't know who made it, maybe Mattel, I don't know, some American toy company came up with this program called Battleship. It was a board, and it's a grid, actually. It's kind of like bingo where they have a grid, right? But you have two players that sit on both sides of the grid. Usually sometimes there's a wall that goes up in between so they can't see where people are putting their ships. And one player puts ships out there, and then the other player shoots the ships. So it's like Battleship. So it's like a war on sea, at the sea. So your ships or your destroyers, or actually here's a frigate, a tender, a destroyer, a cruiser, a carrier. And these are different types of ships, and they take up different types of spaces. So the frigate takes up 2 locations or 2 spaces in the grid. Tenders take up 2, destroyers take up 3, cruisers 3, carriers 4. It doesn't really matter what the ships do. They're just the names of the ships. And what you're going to do then is place your ships on the board, and the way that you shoot each other's ships is the opponents guess where the ships are. So if I'm component, say we have 2 players, A and B, and we have a board full of ships, and we both we place some ships on the board. So player A puts the ships on the board, and he doesn't do anything. He's just waiting to see if his ships are going to get hit. Player B says, okay, what about B5? Nope, missed it. B6. Oh, got one. Oh, I got 1 square of a 2-square board, a frigate, or whatever it's called. Then you go, oh, I said that was B6. How about 06? How about 07? You know, get 2 of them next to each other. If you're intelligent enough, you're going to go, well, if I hit one, probably going to be to the left, to the right, up or down. It's going to be near it probably because they take up 2 spaces. And then if you do that, then you sunk the ship. If you sunk all the spaces that are associated with each one of the ships that are out there, then you sunk the ship. If you sunk the ship, then you're winning. So player B wins. Player A doesn't guess at any games. So player A could be the computer, because the player doesn't have to guess. Or the computer can play itself. So you have one player who puts all the ships out there, and you have another player, who might be the human, and the computer's putting all the ships out. They're guessing the spots, like bingo, actually. You know, and then once they hit all the ships, they won. If they did 60 turns and they don't hit all the ships, then they lose, and the computer wins. So it's a guessing game to see if you can guess all the spaces that are associated. But you know that the ships are certain lengths. So this one here is going to be 4 characters. So you don't know what kind of ship you hit. So you might have hit, you might have hit this ship, you might have hit that ship, who knows. But you start guessing until the computer tells you, oh, you sunk it. You sunk a tender. You sunk a destroyer. It doesn't actually have to tell you what you sunk, but it could. if you wanted to. We're simulating this, and we're simulating it in a 15 by 15 grid. So your program is to play a game in which you try to sink a ship, a fleet of 5 Navy ships, 5 Navy vessels, 1, 2, 3, 4, 5, by guessing their locations on the grid. So the program uses random number positions. I'm going to show you that actually. To position the ships on this 15 by 15 grid, well, isn't that a two-dimensional array? So you're going to store the information in a two-dimensional 15 by 15 array, and the different ship lengths are here. I'm going to demonstrate too. There's a help file that gives you the board actually already if you want to use it. You don't have to use it. So the program must pick one square at a time as a starting location, and then pick the direction of the ships on the board and mark the number of squares so it knows where the ships are in the direction to represent the size of the ship. So if it picked 0, 0, then it can go 0, 1, 0. Well, 0, 0, and 0, 1 would be 2 locations. Or it could go 0, 1, well, it could go 1, start at position number 2 and go 1, or position number 14 and go 14, 15 or something. Or basically you're going to find the starting position and then count off spaces to include the length of the ship. So the user enters the coordinates. So the computer can put the ships out there. Or you can mix it around if you wanted to. The user could put the ships out and the computer can guess at 60. You're playing against the computer. So the computer could guess 60 spaces and you could put the ships out. Or you could guess 60 spaces and the computer could put the ships out. It doesn't really matter. Or you can have the computer do both. The computer can play against itself. The computer could put the ships out and then guess 60 spaces, and you can just stand there and watch if you want to. You don't have to have user input for this. And you certainly don't have to guess 60 times. That's a lot of guessing. So don't make it harder on yourself. Automate it as much as possible. The user enters in coordinates in the range of 1 through 15 for rows A through 0, columns. So in the real game it's like bingo. A19, B32. You know, columns are A, B, C, D. The rows are 1, 2, 3, 4, 5, or 0 through 15. 0 through 14. But you don't have to do A, B, C, D. You could do case switch if you wanted to, you know, for 15. You're not going to run out of alphabetical characters for that. You could go, if it's 0, then it's A. If it's 1, then it's B. Or you could just use numbers. So the user could guess B19. Or it could guess 0, 0. Or actually B is 1. Or 2. 219. A B, 219 or something. To guess all of the different rows and columns if they wanted to. I think it goes rows first. So it's actually going rows and then it's going columns. So 2 would be the second row, first column, second column, third column, fourth column. So it would actually go opposite. It would go 19B because the columns are second. If you're going to do it that way. But you could go use numbers for both. You don't have to use alphabetical characters for one of them. So the program checks the location and reports whether or not there's a hit or a miss. If there's a hit, the program also checks whether the ship has been sunk. If every location If it has hit every location that it occupies, then it's been sunk. So the ship is recorded as sunk if the program identifies which ship it is. And the program is going to identify which ship it is. So you could say, you sunk a destroyer, you sunk a tender, you sunk a carrier, or something. So the user gets 60 shots to attempt to sink the fleet. If the user sinks all of the ships before the 60 shots, then they win. So the computer can win against the computer if you wanted to do it that way. At the end of the game, the program should output the grid so that the user can see where the ships are located. So we have 1, 2, 3, 4, 5 ships that get placed out onto a 15 by 15 grid. Now I put together a help file, and the help file is out here as well. And it is under the, it's right underneath the midterm actually. It's called help, so I don't actually have to go to it. I downloaded it and I put it in, I put it out here already. It's called 909 Battleship.c++. You open it up, it looks like this. I'm going to go through this code in a few minutes. It's pretty quick. I mean, it's pretty small. If I run it, compile and run it, it puts together a 15 by 15 grid for you. So I created the grid for you. And there's some problems with the grid though. I only put 2 ships. I put a destroyer that has 4 spaces and a C for carrier. Well, let's go back here for a second. I put a destroyer. Well, a destroyer is only 3 locations, so you have to change the logic around. And one of the C's, well, we got a cruiser and a carrier. So this is a character array, a 2-dimensional 15 by 15 character array that I put together. You do not have to use this. I'm just putting it out there as a way of getting you started if you're lost. You don't know how to do it. You might have to come up with a different or creative naming scheme. So you can use the first character of the name ship, but you have 2 C's. So one of them could be R, and the other one could be C or something. You have to change one of the characters. So you have an F for this one, a T, a D, and then here's the problem here. You can go, well, what about CR? Carrier, C, carrier, cruiser. I don't know. Come up with something to differentiate the 2. You don't have to use C and C because you can't. Otherwise you got 2 C's. How are you going to know which one is in which one? So you can uniquely identify it by carriers. So here we have a D, and I use lowercase. You can use uppercase. So if I run this again, I got the D's over here. Well, here's the problem with this. You don't have to fix these problems. If you use this example, you do not have to fix the problems. Well, this is word wrapped. D, 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 ooh, D. Well, because it fell off the ocean. It's in the ocean right now. Or it fell off the ocean. It's now off the world. So this word wrapped. So you can use the word wraps if you want. Technically, if it's supposed to take up 4 spaces, it should take up 4 spaces horizontally or vertically. But you might notice that the D's are going horizontal. Let's run it again. Horizontal, and the C's are going vertically. You can leave it that way if you want. So now we got the 3 C's are on the board. I think I only had 2 C's, but no, I had 3 C's before. So we got the C's down here. It's using a random number generation, so every time you display the board, it's different. So the user or the computer, depending on who's playing who, can figure out what's going on with this. And I only placed 2 ships. You want to place 5 ships out there. Well, you just change it around. So let's take a look at the source code example. For the random, you need to include this library here. Standard library. We also have time in here. I think I need that actually for the random number, but we'll see. So you can use this example as a base if you want. You can use the code as is if you want. And just add to it. It's yours for the giving. It doesn't do the whole thing for you. All it does is create the grid for you. So that's why it's called, there's a print grid method. So right at the beginning, we are creating the grid. The grid's a character grid. And we called the name of it grid. It's 15 by 15. So to print a grid, it prints out the current grid. So it does a for x is equal to 0, x is less than 15, x plus plus. Go through each one of them. And then there's an inner loop. Remember I was saying yesterday with the 2-dimensional arrays, we have to go through the rows first and then go through the columns second for or rows or columns and rows, whatever you want. But you have 2 dimensions, so you have a loop inside of another loop. So for integer y, so we're going to use x and y here. So x is going to be the coordinate, x, y, like on a grid. So x-axis, y-axis. So if you go integer y is equal to 0, so inside the x's we get the y's, and y is less than 15. What are we going to do? We're going to print out, this is how the grids get print out. Sets the width to 2, put 2 characters in between. Spaces. And what are we going to do? X and y, grid x and y. So 0, 0, 0, 1, 0, 2, 0, 1, 1, 1, 0, 1, 1, 1, 2, 1, you know, prints it all out for you. So it's pretty basic, but some people might be challenged by this, which is why I gave it to you. And you can use it as is. I'm sure you could probably come up with a better one as well. So this one creates the grid and initializes everything to this underscore, which is what you see out here. Whoops. What is this? Security alert. Do you wish to proceed? Sure, why not? When you run it, you see all of the spaces with this underscore on it. That's where this you could use blank characters if you wanted to. You don't have to put the underscore. I did that so you could see the 15 by 15 grid. And then what you're going to do is replace the underscore with a character, another character. depending upon what kind of boat you're going to stick out there, what kind of ship. So the place ships is another method. So what we do here is in main, it creates the grid, place the ships, print the grid. Create the grid, place the ships, and then print the grid. So this prints the grid. To create the grid, it just initializes everything. It's the same. In fact, we know what? Well, probably didn't have to do both of them. Well, this one just prints it. This one creates it. So it makes everything, initializes everything to the underscore. And then when we print it, just prints it out, whatever's in there. So we do need both. So to place the ships, there's no check for the collision of the ships either. So one ship could actually be overlapped with another ship. You can leave it alone if you don't. If you don't want to fix any of these problems, you don't have to. Just the basic functionality would be nice. But if you want to challenge yourself, you can make it so they don't overlap. All you have to do is put this in a loop and say, hey, you know, if it overlaps, check for the condition. If it does, start over again. Pick another location. Or move it to the left or move it to the right, depending upon what you want to do. I just pick another location, start over. So yeah, we are using time. So we have a seed here, so we're doing 0 to 15. We're picking out a random number between 0 and 15 on the X and 0 to 15 on the Y. Using 15 numbers, so it's going to be 0 to 14 that gets picked out. You can use this as is. It's just a random number generation function. It's using a seed, and the seed's going to be the time. So just setting a random number for X and Y. So we picked a random number for X and Y. We say, okay, well, we're going to put a ship here. So we put a ship here. This is just manually putting the ship out. And then it's going to pick up another random location and put another ship out. So you could possibly, if you wanted to, there's 2 ships being put out here. You could, and this is going this way, Y plus 1 plus 2 plus 2, which is how we're getting this vertical. Because on the columns, it's going this way. So on the Y, it's going plus 1. And then on this one here, it's the X. It's going down. Or, excuse me, this is going horizontally. This one's going vertically. Because this one's going down the X column. Plus 1 plus 2. So you could make these any length you wanted to. You could fix it so all this ship goes this way, all that ship goes that way. Or you can actually randomly decide whether you're going to go horizontal or vertical. You don't have to worry about diagonal. That's way above and beyond the scope of this assignment. You could fix it though and just add, this is just manually putting in 2 ships with 2 random. So you have to repeat the X and the Y random generation for each one of them. Otherwise the ships are going to be at the same location randomly. So you want to pick another location. So that's how the mystery of how the ships are being put out there. No biggie. So this is actually the code that I'm giving you. It's just an example. Because some people will get stuck with the random. Some people will get stuck at how do you put the grid out there? How do you make the grid? So what you could do then is have another function. And when you call the other function here, it could be select. And randomly select between 0 and 60. So if you wanted to go here, you could randomly select an X and a Y between up to 60. Well, is it up to 60? No, it's up to 15, but do it 60 times. So in your loop would go to 60. And then inside of the loop, for each one of the 1 through 60 turns, you'd pick an X and a Y randomly if you wanted to. Or you could add some intelligence to it if you want. Because if you hit 1 and it's right here, don't you want to go X plus 1? So if you hit 1 on your method that's going to, on your function, this is not object oriented, by the way, this is just procedural. But on the function that found 1, because what you have to do is find a location. So you have a loop for 0 through 60, or 1 through 60 or whatever. On the first turn, pick an X and a Y. Okay, just one random. I got one. Okay, 0, 0. And then the program comes back and checks 0, 0. Is there anything there, or is there an underscore? Which is why I put this underscore out here, or blank. So you check for a ship or no ship. Yes, there's a ship. Oh, I hit 1. Oh, great. Then I can try 0, 1, or I could try 1, 0 to see if there's going to be in the 2 adjacent cells. Because I'm at 0, 0, so I can go to the right, or I can go down by 1 to see if there's something else there. And then I know how big it is. So I can build the logic in to stop hitting it. You know, so it goes, okay, it didn't hit this direction, so I hit it this direction. So if I hit it this direction, then, oh good, this ship, and then it says, you know, the feedback comes back and says, you hit a C, or you hit a D. Oh, really? Oh, a D's 4, so let me go another one. Another one. Until it says, or you could just make it so until it says you sunk the ship. So it comes back and says, you sunk a destroyer. You sunk a this, or you sunk a that. So it's just going to randomly pick spaces and then use some logic if you want to put it in. Or you could just have it randomly pick. It could be stupid. You could just randomly, if it found something at 0, 0, and then can go, okay, 12, 10, or something, you know. You could just randomly pick another location out there. But it'd be smart, because that's what the user would do. Just go, okay, I'm going to go to the left, to the right, and go up, down. Because it could go up, down, left, right. So it's just basically practice for you to figure out how to navigate through a two-dimensional array, long story short. But your logic doesn't really matter. You're not being graded on the quality of your game or your user interaction or your... And this is a DOS-based game, by the way. It just looks like this, you know. It just looks like, excuse me, it just looks like this. So it's, oh look, it only put a C out here. Oh, because it went this way. It was going vertically, and it ran out of space. So you could leave it alone, actually, and just, when I hit the sea, oh, you got it, because only part of the ship was in the ocean. The rest of it was already destroyed. But, and then when the user, like, enters something in, like, you know, you could enter in 3, 4, and then you could pull it in, like, C in both of them, actually, and then, or something, or fix the input the way you want it, fix the logic the way you want it. Use that kind of an interface if you want. You don't have to use the blanks. You don't have to use graphics. You don't use anything at all. It's a text-based program. That's your take-home midterm exam. Everybody's program is going to look a little bit different, but you can use this as a base. Notice there's not that much code in here. What I'm giving you is just the... I'm giving you what you probably could figure out on your own. It's a nested loop inside of a print grid. These two loops are very similar, actually. These two loops are practically identical. One of them is just printing it out, the other one is just taking each space and putting a blank in it, or putting a delimited character in there to show that there's something in there. It's initializing it. So this can be the same in all of your programs. Probably will be the same, and hopefully you'll use the same random number generation, because why reinvent the wheel? If I'm already giving you a way of randomly generating a number between 0 and 15, go for it. But all of your other code is going to be completely different, because each one of you is going to have a different idea in terms of how you're going to place the ships, and then what you're going to do with the ships. I mean, some of you might follow this pattern here, but you're probably going to name the ships differently, and you're probably going to have a different order that you're doing it in. So I'm looking to make sure that you're doing it yourself, because this is a midterm exam. So be creative, invent what you want to invent in terms of the logic and the functionality, but make sure you do it yourself when you implement it. I don't want to see two programs that look the same. It's impossible, literally impossible for that to happen. Questions on the midterm exam. It's not due till August 22nd, which is 2 months away, actually. And let's take a look at the syllabus real quick here, actually. Because I can combine this little lecture here before we hit lunch. I can combine it with a review of the rest of the assignments as well, actually. So according to our syllabus, we have 25%, let me make this a little bit bigger for those people sitting in the back. Oops. 25% of the grade is on the midterm, 25% is on the final exam, which again is multiple choice, and the multiple choice exam will be on Sunday at 3 o'clock in the afternoon on August 25th, I guess. So I think the 24th is Saturday. It's on the Sunday. The other 25% is the CSLO essay. So I don't know if I've gone over the CSLO essay. I know I've gone over the first 2 assignments, but let's just take a look here. Spend some time before lunch, I guess, going over the assignments. I might have it downloaded already, and I do not. Let's take a look at the CSLO essay. The internet is running a bit slow. Let's see. We're challenged. Click, wait, click, wait, download, wait. So the CSLO essay is another opportunity to pick up 25% of the grade. Let's take a look at that for a second. And my sources tell me that turnitin.com has been implemented, which is probably why the EMS is running on the slow side. Who knows? But which means I won't even get to say. It's sort of like attendance. I won't have a say in it at all. You turn it in, it matches somebody else's CSLO, or matches a student who turned it in before in the past. Because this is the same CSLO I used last time, actually. Then I don't even get a say in it. You just get 0 points for it. So, which means, and Turnitin is a plagiarism checker, by the way, so it will check it to make sure it doesn't match anything. It's a no-brainer. It actually cuts down on the amount of grading I have to do because it will immediately eliminate all of the repeated resubmissions, so I don't have to worry about it. It's amazing what goes on at this school. All right, so what do we have here? We have write a 2 to 3 page double-space essay on a topic of your choice. Select one of the topics, only one. So you have to use at least 3 reference citations. What does that mean? You need to go out and do some research for this. You can use the textbook if you have a copy of the textbook, PDF files of the books, whatever, anything you want. Now your research should be performed to gather the information that's going to be used in the paper. A reference citation is a quotation where it says, so-and-so said, quote, I like C++, end quote, open parenthesis, Hacker, comma, 2013. And then in the bibliography at the end of the page, it says Hacker, Barbara, 2013, I don't know, BS about C++. Name of the book, you know, it's a reference citation for those people who are not familiar with the concept. So your paper must reflect your own writing. And as I mentioned before, not your handwriting, which is amazing, the questions I've had. And it's not your handwriting, it's your own writing, typing, your own words. And cannot contain portions cut and pasted from the internet or other sources. All papers will be passed through Turnitin.com plagiarism detection tool. This was actually when it was done manually last time we did this. If your paper ends up being plagiarized or not your own work, you'll receive a 0 credit for the assignment, no questions asked. This opportunity is to practice your writing skills. And papers in English. So, topics, you got 6 topics to choose from. And you can actually feel free to, number 6, pick an object-oriented or C++ topic of your choice. The topic doesn't really matter. So pick something that you're interested in. It's related to C++. If you recycle, I've had this before too. You know, like it was, I can't remember what class it was, but I got, well yeah, it was client server. I got classes from my Java EE course. I got papers that were for C++ and for client server and the internet. These other classes I didn't even teach, really. I got CSLOs for those classes in there. Make sure it's on C++. Object-oriented programming in C++. Discuss the concepts. Okay, so number 1, you can just pick, like, you know, discussing the concepts themselves. Number 2 is the differences in the implementations between C++ and Java. That's a no-brainer, actually. Actually, if you like to compare languages, that's not a bad one to look at. You can compare C++ and Java. You can look at what is recursion. We're going to talk about recursion. Might even get to it later today. I talked about a little bit about it as well the first weekend. Common problems associated with pointer variables. I'll talk about pointers. Linked list, if you're so inclined to learn more about linked list. Pick a topic of your choice. You don't like any of these? I don't know why there's a box at the end, but this is really weird formatting. I don't know what the box is, but there's only 6 of them here. Pick a topic of your choice. Select a topic relevant to object-oriented programming in C++. good opportunity to do some research on a topic they might not be familiar with that you want to learn a little bit more about. So, questions on the CSLO essay or the midterm? Then I'm not giving any support materials on this. You can feel free to use whatever you want, as long as you write it in your own words, actually. The best way to write to paper is just open it up, a blank piece of paper or blank notepad or WordPad or Microsoft Word file, and just start typing it. And then put in 3 reference citations. You can have as many sources as you want, but you want to have 3 references inside of the paper. Most people don't do that. Some people haven't been doing that, where you actually quote something or paraphrase something or cite something. Reference it. It makes no sense to do the work if you're not going to put it in the paper. So when you put it in the paper, you're saying, according to such and such source, this is the case with C++ or something. So to paraphrase means you take somebody's words and you switch it around. So if I said, I really like C++, then I'm going to paraphrase that. Okay, Barbara Hacker says she likes C++. So you're mentioning who said it. According to Deedle and Deedle, pointers should be used with caution. Because on, page 5, and on page 5 he says a whole diatribe about how pointers are risky and yada yada yada. So you're paraphrasing it. You're not saying exactly what he said, but you're rewording it so it's your own words to describe what he said. So, at the Battleship game, according to B Hacker, the Battleship game can be played against a computer or something. I don't know. You're making something that has some logical reference to your paper, and you're doing it 3 times. That means you don't put 3 references at the bottom of the page. You put 3 inside the paper. Sometimes they're referred to as inline citations. They're in the text. In-text citations is what they're called. So. Questions about in-text citations? Or no? All right. Let's take a memory. Let's go through memory lane on the assignments here. Assignment number 1 I went through already. I've actually still had some questions about it, believe it or not. And some of you are doing a great job with the assignments. I've reviewed some things already where you've sent me email messages and said, hey, is this okay? It is okay. And if I come back for you to do that, and if I come back and I tell you it's okay, it means it looked good. It met all the requirements. If somebody else turns in the same one, it turns into being not okay. So just because you showed it to me, this happened actually last term. Just because you showed it to me and I told you it was okay, it didn't mean that it was okay to give it out to 15 friends to also turn it in. That's not okay. So if that happens, although everybody, including you, gets an F on it. So it's okay when I say it's okay. Yeah, this will earn you full credit or something. If you're the only one who turns it in. If everybody else turns it in, it just went from being okay to not okay. Or there's also the chance later on, if it's plagiarized and I don't catch it on the first try, later on I realize, oh, wait a minute. This other guy, he's used the same source code. This happens too. And you go, wait a minute. This was also very similar. Because, after I look at a dozen of these, they all start looking. I see the similarities among all of them. And I go, wait a minute. I thought she did this on her own. Or I thought he did this on his own. Now he copied it out of a book. Wow, look at that. I just changed the variables around a little bit. And then it goes from being okay to not okay. So it's not a 100% guarantee. If this no problem was associated with it, I look at it and I tell you it's okay, then it's okay. If there's a problem with it, then it goes from being okay to not okay. Okay? Good. We're all good. We're okay. Problem number 1, yes, I know the formula is wrong. This formula is wrong. It will give you wrong results, depending upon what date you turn in. The grade on assignment number 1 is not associated with your ability to fix the formula. In fact, they've given you multiple versions of the wrong formula. If you go on Wikipedia, you might actually get the right formula. Who knows? There's so many things to consider. Leap year, I don't know. You can actually, in some instances, rare, time zone, daylight savings. If it's at midnight and you put the number in, it might be 1 o'clock in the morning somewhere else. Might be a different day. I don't care. I don't care if the formula is wrong. I'm not giving you the right formula. I'm giving you a wrong one to begin with. Although last time we tried it, it actually worked a couple of times last month. So I think because this year we had February, we had 29 days in it, and I don't think it keeps you leap year. I don't know if that's the case or not. But anyway, long story short, I don't care if the formula is wrong. Formula can be completely wrong. What you're trying to do is fulfill the requirements of the assignment. The assignment wants you to write a function. You don't put a function in there, then you're not going to get any credit at all for the assignment, regardless of how well you fixed the formula. You need to put a function in here. So the learning objective here is to put a function in. So, and also use the C in and C out. So you're going to design it here. You're going to write a program that determines the day of the week given a date. And you invent your own complex algorithm or use this one. And it uses a function for it. So your program should make appropriate use of the value returning functions to solve the problem. You're returning a value from the function. So don't put all of this stuff in a function, call the function. You know, main has one line of code in it. It says, you know, here's the function call. And then the function does everything. We want to go back and forth between the functions. So make use of the value returning. Requires 9 digits. Well, anyway. Questions on assignment number 1. Assignment number 2 I also went over previously. And assignment number 2 has, it's easier. I know I was helping a couple people with this yesterday, actually. It's easier than the employees and the person that we created. If you want to use the employees and the persons that we created, and we threw a dog in there too. And the last weekend that we met, and also in yesterday's examples, you may use any of those examples as is, as long as they're my examples that I've told you that you can use. The ones we've used in class, you can use. So you're having problems writing the program, download the example. Remove all the stuff that doesn't belong in there. First one doesn't work with inheritance. The first one works with an employee class. So create the employee class. We already have an employee class, but I think it only has ID in it, and it's inheriting everything from person. You want to leave the inheritance in there, go for it, but just add the information in there for the salary and all the other functionality. And then, you know, you have to change the main program to demonstrate the class. But we went over this one last weekend as well. It is simply writing a class definition for employee and using an employee. So it's not too rocket science-y. It's just a plain old employee class. Not quite as complicated as what we did in class, actually. It's a little easier. Assignment number 3. And you have 2 months to work on all this stuff, by the way. So. Assignment number 3 I have not gone over as far as I can remember. So let's do this one a little bit slower. Gives you practice using pointers and understanding pointer-related terminology. So I give you the code again. In fact, it should be out here, but let me just make sure. Assignments. So assignment number 1 with all of the, oh, assignment number 3 isn't, oh, here it is. Wait a minute, assignment number 5. Oh, no, this one doesn't require code. Assignment number 5 does, okay. So this one doesn't require any external code. So what are we doing here? I give you the code actually in the assignment. It's at the bottom, I believe. It is. So here we go. So in this particular assignment, you're going to practice calling a function by reference and using pointers with structures. And I want you to use a structure, not a class, and follow the instructions as they're given. So read this description carefully as you proceed through each one of the steps. So number 1, copy the source code below into a file called struct.c++, or a file name of your choice. You don't have to call it struct.c++. Well, this is the source code down here. And it creates a structure. Leave the structure alone. Use the source code. Creates a structure, and the structure has a character name 20, and has an ID, and it has a mark or grade. And then in main, we create a structure called STU. This is a student structure. And we give it a name. We have a variable that's going to store the name, and integer I. And we're going to say, your name, please enter your name. Get the line with the name. And puts a string. String copies the string into the student name. And basically populates the structure. And so we have this kind of thing going on here. Create a function and pass the structure pointer to it. So you're going to pass the structure as a pointer structure, to a function. So the function is not in here. You have to create the function. And in the function, we're going to modify it so that there's a function to initialize the values in the student instance. So all that stuff to get this stuff from the user and create it, we're going to do it inside of the function. So you're going to pull code out of here. You can pull the same code out if you want. Just like the day of week, you could pull the code out of the example, stick it in a function, make the function work for you. It's very similar to the first assignment actually. You're creating a function and you're just going to call the function. But this time we're going to work with the pass by value versus pass by reference, and we're going to populate the information inside of the function instead of inside of main. The parameter to this function must be the address of the structure instance, and you declare an instance of student for a new student and then pass the address of that instance to your new function. Don't create a function and then inside the function create the instance of this and do everything inside the function. You want to create the instance of the student structure outside of the function. Pass it by reference, so inside of the function you're going to populate the name and the grades and everything. And you're going to do it by reference, so you don't have to pass it back out. The function doesn't necessarily have to have a return to it. It just has to take as a parameter the address of the structure you want to change. So it's showing you a more efficient way of doing it. So instead of taking it, populating it, and then sending all the information back to main to go populate this function, populate the structure, you're going to do it inside of the structure. And then when you're all done, because you passed it by reference, it's already changed. You don't have to pass anything back out of that function. It's already changed for you permanently at the memory address that you gave it, which is the structure you created. So, and you only have to do it for one. You don't have to do a whole loop to do a bunch of students. You only have to do it for one structure instance. So pass the address to the new function. To give you some help, this is what the first part of structure.c++ should look like. Yeah, it creates the structure. And then we have void, initialize student. You don't have to call it that. There's two different ways of doing this. I'm not going to tell you the two different ways, but this is one of the ways. You may use either way that you want. You don't have to use this way. So this one's taking it. You can also accept the address of. So this one's taking a structure that is of a structure called students, and we have the asterisk here. If you remember from yesterday, it's a pointer to a student. You could pass the pointer, or you could pass the address of the pointer, and you can accept the pointer, or you can accept an address, which is the pointer. So don't worry about following this to its identity. You can do it this way, but you don't have to. If you figured out another way of doing it, and there's multiple ways of doing this, you may use any way you want, as long as you're passing it by reference and you're not returning anything back out of it. Remember, this thing is void. Function's void. It's not returning anything. So you need to add a line to the main function to declare an instance of student, and then add another line to call the new function in its student, feeding it the address of, that was a hint, of the new instance. So you need to add the function to the bottom of the file to initialize the structure. Don't forget to use the member selection operator, this one here, that we're using the arrow instead of the dot. You remember that? A statement to initialize the name must throw some off track, so we'll give you it here, string copy. We just went through the string copy stuff anyway, but string copy name is going to be equal to something. Don't worry about it being fancy. Just make it work. It's a simple exercise to have you play with pointers, compile and run the program. So create a function. This is part 2. So part 1 is create that base program. Part 2 is copy the stuff that populates the structure information, put it into a function, call the function by reference. So And the function doesn't return anything, it just creates the student for you when you call it. Part number 3, just create a function to display the contents of the instance. So at this point, you can't really tell if you've done anything, if the instance is actually populated, so print it out. So you need to convert those statements at the end of the program, and it's given for you as well. It's down here at the bottom. So the code sequentially goes through, populates the structure, and then prints the structure. So you're going to take the code to print it. You can modify it. It doesn't have to be the identical code. You can modify both of them. You can modify how you're creating the instance of the structure, how you're populating the data, and you can also modify how you're printing it out to the screen as well. So what you're going to do then is create a function and call it from main, and again pass the function address, pass the function the structure address instead of, so you're going to call both of them by reference. Send the structure, the address of the structure to it, and use it as a reference inside of there. You can use constant with that if you want, and you won't be changing anything in there. Constant can be used with more than just arrays. It can be used to print out stuff as well for printing function. You don't have to. It's optional. Now you've already got the code right down here. Just cut and paste it and put it into different parts. You're separating it out. I do expect most of your programs to look very similar, although I can tell if you've copied this one. It depends on what technique you use, because there's more than one way to do it. Actually, there's a couple of different ways of doing it. But you're going to have expect some similarities, because I want you to cut and paste and use this code. You don't have to use it, but you can, and you probably will, because it's easier than reinventing the wheel, writing your own code. So expect there to be some similarities with this assignment. It's just the only assignment I would expect there to be some similarities with, actually, in terms of its design. Questions about assignment number 3? No? Okay, we've gotten through that part as well. Let's take a look at 4. 4 and 5 are pretty easy, actually. Number 4, oops, we're going to break for lunch soon, don't worry, is the dinosaurs. I've actually gone over number 4. I went over it last time in this class, I believe. This is the one you can really use the code that we went over in class with, because that one is doing inheritance, and the dinosaurs are doing inheritance. So what are we doing with the dinosaurs? You're going to create Dino. Dino's a dinosaur. Isn't he kind of like person? Person, Dino. And then when we create an employee, that was a kind of person. Well, that's another dinosaur. You're going to create 3 more employees, or 3 more dinosaurs. So you're going to have a base class Dino, and Dino's going to have several basic characteristics like a name, a height, a weight, a movement maybe, speed movement, a diet perhaps, something associated with him. You're also going to have several basic behaviors, eating, moving, sleeping, stuff like that. So like person had weight and stuff like a name and stuff like that in there. And then your assignment is to define and implement the generic Dino, or dinosaur class. You can call it Dino, you can call it dinosaur, whatever you want. And that defines these basic characteristics. And then the behaviors are very basic, so make it as basic and as generic. So all dinosaurs have the same characteristics, these Dino characteristics. And then you're going to create and make and represent 3 other dinosaurs. So they're sort of like the relationship between employee and person. So you're going to have an apis, you can call it an apa, triera, and a hadro, or a hadrosaurus, whatever. I can't even pronounce these things. This guy is slow moving and he eats herbivore. That's plants, and he's very large. This guy here, he's a carnivore. He's fast. He's large. This one's medium sized. He eats plants. So give them some different characteristics. Make some different. Be creative if you want. And then for each one of them, add at least 2 additional pieces of information about the specific dinosaurs. You can give 1 teeth, 1 a tail. You can set the number of eyes on one of them. Dinosaurs are funny because you can make some interesting looking dinosaurs. You can give 1 hair, make 1 skin, just skin. I mean, make 1 dark skin, light skin. Make 1. I don't know, give 1 an afro or something. I don't know. Just make your dinosaurs as unique as you want. Add some different characteristics to them. Customize at least 1. So you want to override you want to override it, overload and override methods. So you're going to customize at least one of the sleeping, eating, movings, which means you're going to override it. It means you're going to create a new behavior. We did that actually yesterday. So you're going to take and print something else to the screen. So instead of the Dino says, I'm sleeping, and then maybe your Hadrosaurus is going to say, I'm sleeping with coughing and snoring as well, which means you overrode it. You customize the behavior, at least one of the base. So take the base class behaviors and overload or override. So either complement it, add something to it, or change the behavior so it's doing multiple things. No mention in here on the constructors. You can overload the constructors if you'd like as well. Makes your job easier, actually. So if you remember how to overload the constructors from it's actually in the employee and the person example. You can take the employee and send the stuff back to the person. Take and create this guy here and send the stuff back to the Dino. So Dino's name and stuff can get populated. Once you have these three, write a little small program, create one of each, and have them go through some of their behaviors. Demonstrate that the dinosaurs work. You can do that any way that you want, actually. So this is the fun one. Actually, a lot of students like this one because then you can be creative with it. And you only have to go one level. If you can go one level, you can go 20 levels. It's the same thing. You just go up a different level. So, inheritance is inheritance, regardless of how many levels you put in there. So go to Dino and go 3. So you have Dino at the bottom, and then you have 3 at the top. 3 different ones. Questions on Dino? Last but not least, number 5. There's only 5 assignments for this course, and they're worth 10 points. How many are they worth? 5 points? 5 points each? Total 25 altogether, I believe. I actually still have it out here, don't I? No. Here it is. There are 5 assignments worth 5 points each, 25%. So all 5 of these assignments are worth the same as that midterm exam, which are worth the same as that CSLO. So don't stress on the assignments. Just do what you're supposed to do for them. They're not supposed to be that time consuming, although you'll learn more from doing the assignments than anything else probably, because that's the practice that you're going to get. So let's take a look here. I don't need that one. Assignment number 5 is the linked list assignment. And you have a link LL list C++ and LL list H out here. I'm giving you a completely working linked list. It works just fine. You just add some methods to it. So what you're going to do with this one is you're going to take a look here. Let's make this a little bit bigger. In this particular assignment, the purpose of the assignment is to demonstrate the operations of a simple singly linked list, which means there's only one direction. I'm going to talk a little bit more about linked lists this afternoon as well and show you a little bit more examples as well. I just started on that concept. What I've been doing is kind of like rotating through a bunch of concepts, make it more interesting. Otherwise, if I spend hours talking about linked lists, you're going to be sick of linked lists. Hours talking about pointers, you're going to be sick of that. So if you break it up a little bit, rotate the discussions around a little bit, makes it more interesting for me too. So download those 2 files, linkedlist.h and linkedlist.c++, and then make the following modifications. So add the code to print out the linked list. You have to figure out how to loop. I got tons of examples that do looping, actually. In fact, I gave you a couple yesterday. And I believe that is uploaded, but let me just make sure real quick. The linked list examples, I know I put them with the video. Hold on 1 second. I think I put them in miscellaneous. Oh, linked list examples. We have some here. Yeah, we got super easy in here and easy list in here. So there's a separate section for linked list examples, and there's a separate section for inheritance. And then in the miscellaneous examples, I believe I also stick. Which one is this? I think I need to put it down from yesterday, but it's also on the video. It's on the video from yesterday, but this is a good note to self. I need to add that to the list. It would be lecture. It was the lecture we had yesterday. I gave you super easy and easy, but they're also in the linked list directory, so I guess it doesn't really matter if I put them there or not. But it's on the video as well. So you're going to add the print method. You're going to add the code to add a single node. So insert a node and then to delete a node. And that's all you got in this assignment. So you're going to take the code and add 3 methods to it. And the 3 methods are pretty generic, actually. So I'll wait until we hit the linked list stuff again this afternoon, and then I'll revisit this a little bit. I'll show you. But just actually don't even have to revisit it. Just know you're going to print out the linked list, you're going to add, and you're going to delete. So you're going to modify the code example. You may also make any other changes that you'd like. You don't like the name of a variable, you don't like the way something is structured, change it. You don't have to keep it the same. All you have to do is make sure you add these 3 functionalities to it that are missing. There's space holders in there. Actually, the methods are created, and in there it says, put the add code here. Put the delete code here. So that's the no-brainer way of doing it. Otherwise, you don't like it, you can rewrite the whole thing. Make sure, though, it has these 3 methods in it. So. And that's the 5th assignment and the last assignment for this course. So you guys have lots to work on for the next 2 months, actually. And let me end this video because this is all about the assignments for the course. So, the midterm exam, CSLO, all of the assignments are due on August 22nd. So you don't have to worry about turning anything in until the very end. But I wouldn't wait until the 21st because actually even now the EMS is running a little bit slow. So I'd put them in as soon as you got it done. As soon as you have everything done, just stick it up. Not everything, just say you have one item done. Put it in. Another item done. Put it in, put it in, put it in. Because lo and behold, it's just like the attendance this morning. Something will happen. And then you're stuck. And I can't do anything for you. You don't make the deadline. You don't make the deadline. So, alright, it's time for lunch. So let me stop this video.